Hi, everybody. Please let me apologize. Right in the middle of the lecture, the recording stopped and I got a message that my computer memory was full. So I've had to dump a bunch of files and so forth and so on to make room for the rest of this lecture. But let's pick up from where we were. We're showing that the composition of onto functions is onto. So we have a function f from set x to set y and a function g from set y to set z that are both onto. And we're going to show that g composed with f from x to set z is onto also. So we let the hypothesis be given. We suppose that f from function x to set, function f from set x to set y is onto. And we suppose that g from set y to set z is onto. And to show that the composition, g composed with f, from set x to set z is onto, we're going to pick an arbitrary element, little z, in set z. And our goal is going to be to show that there's an element in set x that gets assigned this element, little z, in set z, by the function g composed with f. So again, we pick some arbitrary element, little z, in set z. And what can we do with our hypotheses? Well, part of our hypothesis is that g from y to z is onto. And since it is, there exists an element, and we'll call it y sub z in y, such that g evaluated at y sub z equals little z. And this element y sub z exists because g is onto by hypothesis. So there is some element y sub z in set y such that g evaluated at y sub z equals z. Now we're going to use the other part of our hypothesis, namely that f from x to y is onto. And since f from x to y is onto, there exists an element x in set x such that f of x equals y sub z. And I'll tell you what, just to distinguish this element x from every other element x in set x, we'll call it x sub little z. So because f from x to y is onto, there exists an element in x, we'll call it x sub z, such that f evaluated at x sub z equals y sub z. Now all we have to do is show that the function g composed with f evaluated at this element will give us little z in set z. Or to say it differently, we have to show that g composed with f assigns the element little z in set z to this element x sub z in set x. On your mark, get set, go. We're going to take this element, x sub little z in set x, and we'll plug it into the function g evaluated at f. Now, just for the sake of visualizing things a little bit better, I want to rewrite this. Sometimes I like this notation, sometimes I don't. This is one of those times I don't really like it. So I'm just going to rewrite it as g evaluated at f of x sub z. Now, What do I know about f evaluated at x sub z? Let's see. Down here it says that f evaluated at x sub z equals y sub z. Okay. So then this is g evaluated at y sub z. Now, what do I know about y sub z? Well, over here, it says that g evaluated at y sub z is equal to z. Technically, our proof is finished right here. But for the sake of any who have been watching us and they are verifying what we do from step to step is correct, but maybe they've lost sight of the big picture, we're going to recap what it is that we just did. And here's where we started. We said let little z be an element of set z. So, given little z in set z, and what did we do? We showed there was an element x sub z in set x such that g evaluated at f of x sub z equals z. That's what we showed. Hence, g evaluated at f from x to z is onto. And that completes the proof.